Hi guys, good night everybody. Just let me know if you guys can hear me before I start, please. Alright, great. Alright, let's have a look at this first question here. Which of the following processes provide evidence for the particulate nature of matter? Right? Here's what to do for me. All I want you to do is to put the question number and put what you think is the answer. Right? So this is Q1. So just put Q1 and put what you think it is. Right? Alright, people saying the answer is B. Let's check that. So we're talking about the particulate nature of matter here, right? Let's know. Okay, so diffusion, yes, diffusion can be explained in terms of the particulate nature of matter, right? Filtration, nope, that's not the answer for that, right? Osmosis, yes, right? Keep in mind that Brownian motion is another evidence that supports the particulate nature of matter. So the answer will be 1 and 3, which will be B. So make sure you all select the correct answer after reasoning the question. So that's question 1. Question 2. So we have a table here, and it shows the melting point and the boiling points of the chlorides of 4 elements. Which of the elements forms a chloride that is ionic in nature? That's the answer for this one. So just put Q2 and put what you think is the answer, right? That's how I'll differentiate your answers, guys. So put Q2 and put what you think is the answer. So I'm seeing a lot of people saying the answer is C. Let's check that. So we're talking about, they said which one is ionic in nature. So when they say ionic here, we're talking about something, we expect the chloride to have a very high melting point. So what you'll do, you'll look at the answers here, and you look to see which melting point of the chloride is highest, right? As well as the boiling point. So based on the answers that we have here, right, this number, 973 is the largest. 1693 is also the largest. So therefore, we're going to go with C as the answer. All right. That's number, so this one here is number 3. So we have some elements here. So we have arrangement of electrons in atoms X and Y are 285, 286 respectively. Which of the following options represents X and Y? So people saying the answer is B. Here's the reasoning behind this. If we have X and the electronic configuration of X is 285 and Y has electronic configuration 286, here's the reasoning behind this. So this number here will tell us that this belongs to group 5. And if you all remember the periodic table, group 5 elements are non-metals. So this has to be a non-metal. And this here belongs to group 6. So this is also a non-metal. So we're looking at the electronic configuration to figure out the group. So in this case here, both of them are expected to be non-metals. So yes, the answer is going to be B. What about question 4 here? Which of the following best describes the formation of a metallic bond? Right, some people ask about maths, so hopefully I'll get a chance during the week. People say the answer is C. Let's check that. So we're talking about metallic bonding here, right? Metallic bonding. So with metallic bonding, we have positive metal ions held together by a sea of electrons. So if you look at the answers here, the only one that kind of makes sense is going to be C, because positive metal ions are referred to as cations, and they are held together by a sea of mobile electrons. So yes, the answer is going to be C for this one here. What about question 5? Which of the following elements does not form simple ions by gaining or losing electrons? I'm not sure why people ask about physics paper 1. That's gone already. You can't do anything about that. Right? Plus, I haven't seen the paper, so I don't know. Right? So people are saying the answer is carbon. Yes, right? Carbon is 12,6. This electronic configuration here is 2,4. Carbon belongs to group 4. Because of these 4 electrons here, carbon does not easily form ions by gaining or losing electrons. What happens here is that carbon is able to form covalent bonds. So the answer is going to be A for number 5. What about question 6 here? Some students misinterpret this particular question though. Element X has 8 electrons in its outer shell. Which of the following are possible isotopes of element X? Question 6. Just remember to put the question number, don't just put the letter, right? So I know which one you're thinking is the answer. A lot of people say the answer is E. So we're talking about isotopes. So when it comes to isotopes, we have the same number of protons. So the protons need to be the same. And the number of neutrons need to be different. So in this case here, let's look at the answers. So in A, we have 8 protons. So we have the same number of protons, but the number of neutrons different. So that kind of making sense. And also, when it comes to an element, the number of protons must equal to the number of electrons. So if they told you that you had 8 electrons, now this is the part that has some students confused, and even for me, there is a little challenge here though. Because if you have 8 electrons in your outer shell, now we don't know how many shells we have. There has to be electrons in the first shell. So technically it should be 10. So I see an issue with this question. But the only answer that makes sense here is actually going to be A. Let's double check the others. C is wrong because you have different number of protons. So that's two different elements. D is also wrong because of the same reasoning. Say different number of protons, so two different elements. When we look at B, you have the same number of protons, but different number of neutrons. But the thing is, the number of protons technically should be equal to the number of electrons. Now, really and truly, I find that none of these answers are correct, but the closest one there will be E. Because if you have 8 electrons in the outer shell, then we can have an electronic configuration as 2,8, which will give us 10 electrons. Or we can have 2,8,8, which will give us 18 electrons. So technically, none of the answers is correct, but we have to go with E in this case here. Right? Somebody's asking if the protons can more protons than electrons. It is possible. Remember, an element can either gain or lose electrons. If you have more protons, then it has an overall positive charge. So that's number 6. Number 7, we have mass number. What is mass number here? Okay, so people saying the answer is C. So mass number is simply the number of neutrons plus protons. Yep, I agree. The answer is C. Question 8. The mass of 1 mole of atoms of an element refers to the quantity of. So even the wording of this one, I'm not too comfortable with the wording, but there's only one probable answer there. So people are saying the answer is B. Yeah, I agree the answer is B, right? 1 mole, we're talking about 1 mole. 1 mole of atoms is actually 6 by 10 to the power 23 atoms. So 1 mole of any substance contains 6 by 10 to the 23 particles. That's referred to as our Avogadro's number. So that's number 8. Number 9 is based on rates. Now, generally, chemistry questions, you have to read them carefully. Sometimes the questions are loaded, so you have to read carefully the answers. So let's have a look at this one here. So some calcium carbonate was reacted with excess dilute hydrochloric acid. The volume of carbon dioxide evolved was recorded and plotted against time. Which of the following graphs represents the reaction? What are we talking about here? What's the answer for this one? Alright, so I'm seeing people saying answers A, yes. When it comes to calcium carbonate plus hydrochloric acid, you're going to produce carbon dioxide. So the amount of carbon dioxide over time is going to increase. So we expect to get a curve. So the only one that makes sense here is going to be E. So that's number 9. Question 10. We have some particles here, V, W, X, and Y. We have number of protons, number of electrons, number of neutrons. Which of the following particles represent an anion? For question 9, the answer is not D. The answer is not D for question 9 at all. Okay, so I'm seeing people saying the answer is D for this one here. Let's see what's happening here. Okay, so which of the following form an anion? So when it comes to an anion, it has a negative charge. So an anion has a negative charge. So that means that the number of electrons has to be greater than the number of protons. That's essentially what we say. So we need to look at the table and wait, that's not. What did you all put? A lot of people. Okay, so some people said D, some people said C, right? So we have to look to see which one do we have more electrons than protons. So if you look at D, you will notice that you have 18 electrons and you have 16 protons. So overall, Y is going to have a negative charge, which is going to be an anion. So yeah, I agree. The answer is D for that one. Okay. So that's number 10. Number 11 here, we have 11 and 12 is based on these answers. So question 11, this one here. Which of the following substances above can be described as the oxide of a metal? So the following is the oxide of a metal. So a lot of people tell me the answer is a base. Yes, a base is what we refer to as the oxide of a metal. What about question 12? Which of the substances above supplies protons as the only positive ions in aqueous solutions? So people are saying the answer is D. What is D? Acid? Yeah. An acid is a proton donor. So therefore, number 12, the answer is going to be D. Question 13. Which of the following statements is true of an endothermic reaction? Which is true for an endothermic reaction? Alright, but any answer is B. Let's check. So first of all, when you read the question, you have to remember what an endothermic reaction is. So an endothermic reaction, if I have a chemical reaction taking place in a test tube here, and I have a thermometer inside of this, what's going to happen is that it is going to absorb energy from the surroundings. That's an endothermic reaction. If I were to look at an energy profile diagram for what's happening here, So we have energy and we have progress of reaction. So endothermic reactions look like this. So this is your energy content of your reactants. This here is the energy content of your product. So therefore, this here will represent my energy profile diagram. So the distance from here to here is what we refer to as delta H, or your enthalpy change. And the distance from here to here is what we refer to as the activation energy. So this here is your reactant, this is your product. So if it's an endothermic reaction, let's see what's happening here. So heat is given up to the surroundings. Nope, that's an exothermic reaction. Heat is absorbed from the surroundings. That is correct. The products have less energy than the reactants. This is not true. That's an exothermic reaction. The products have the same energy as the reactants. That's also not true. So the answer is going to be B for this one here. So that's number 13. What about question 14 here? Right, question 14. Like I said, put Q14 and put the answer. So I know which answer you're referring to, right? So people are saying the answer is B. Now you all need to be able to, you need to know how to calculate this, right? So the concentration of the potassium chloride is 60 gram per dm cube. Now they want you to figure out what's the mass of potassium chloride in 25 cm cube. So based on the concentration data, you can see, so it's 60 gram per dm cube. So that means that in 1000 cm cube of solution, we actually have 60 grams of potassium chloride. So that's KCl. Therefore, if we have a sample that is 25 cm cube, then all we need to do here is to cross multiply. So this will be 25 by 60 divided by 1000. So this is going to be 25 multiplied by 60 all over 1000. And that's going to give me 1.5. So this here is 1.5 grams. All right, so C is the answer. Yeah, I agree. So that's number 14. We have a sample of lead nitrate. It's heated and it decomposes, giving off nitrogen dioxide and oxygen. The balance equation for this reaction is what? Yes, you are allowed calculator in the chemistry paper 1. You can use it, all right? Right, so people saying the answer is A, yes, right? So keep in mind, in case you see this in the multiple choice, nitrogen dioxide is a brown gas, and lead nitrate decomposes to give me lead oxide, nitrogen dioxide, and oxygen. So in terms of balancing, we need a 2 here, a 2 here, a 4, and that's it. So that's number 15. Number 16. Item 16 refers to the following information. So we have some elements here. which two elements above, when combined, form mainly ionic compounds? Okay, so people saying the answer is B. So you want to form an ionic compound. So you need to react metal plus a non-metal in order for you to get an ionic compound. So what we need to do, we need to write out the electronic configuration for each of these here. So this is 2,1, this is 2,4, this is 2,8,7. This here is 2,8,8. Now, based on the data we have here, so this belongs to group 1, so this is a metal. This one is group 4, so this is a non-metal. This one here is group 7, so that's also a non-metal. And the last one here is also a non-metal because it is group 8 or group 0. So if you want to form an ionic compound, we can take this group 1 metal and you have to select the correct non-metal. The only non-metal there that it's going to react to it to give us an ionic compound will be 1 and 3. So the answer is going to be B. So that's number 16. Which of the following mixtures can be referred to as a standard solution? Which of the following is a standard solution? Everybody saying D. Alright, so we're looking at the word standard solution here. Now a standard solution is a solution whose concentration is known accurately. If you look at these answers here, in part A we have iodine in 50 cm cube of ethanol. This does not tell me how much iodine I've added to the ethanol, so that's not a standard solution. 30 grams of sodium chloride in water, that doesn't tell me anything. Sodium chloride in 50 cm cube of water, nope. 30 grams in 50 cm cube of ethanol, that's a standard solution. You know exactly how much iodine you've added to that ethanol, so that's correct. That's number 17. This next one here, we have 18 and 19 refers to... Okay, so we have some answers here. And the first one, question 18, which of the terms above describes the structure of sodium chloride? So which one describes sodium chloride? Look at the words. Okay, so people are saying the answer is A. Yeah, sodium chloride is an ionic compound, so that's correct. What about 19? Which of the following terms describes the structure of copper? Which term describes the structure of copper? Okay, people saying the answer is D. So copper is a metal, so we expect metallic bonding to be here. So D is the correct answer. D is the correct answer. So that's 19. Which of the following oxides react with both acids and bases? Which of the following oxides react with both acids and bases? Okay, people saying the answer is C. So when it comes to, so they're telling us, so we have different kinds of oxides. So we have basic oxides, we have acidic oxides, we have amphoteric oxides, and we have neutral oxides. If you have an oxide that reacts with both an acid and a base, it's called an amphoteric oxide. So that's what we're talking about here. It's called an amphoteric oxide. Now, amphoteric oxides could be zinc oxide, it could be lead oxide, right? And it could also be aluminum oxide. So these are our amphoteric oxides that we should be familiar with. So we're looking for an answer that is one of these here. So if you look at the answers here, aluminum oxide is actually one of them. So there are multiple versions to this question, so just be aware of that. What about question 21? I know students who like oxidation reduction. The equation for the reaction of silicon with chlorine is given by this here. In this reaction, silicon is a reducing agent and is what? So students are saying 8. Now there are several ways you can work this out. So you have silicon plus 2Cl2, and that's producing SiCl4. Now in terms of oxidation numbers, so you can look at it in terms of oxidation number, but you don't really need to, because they told us here that silicon is the reducing agent. Now if silicon is the reducing agent, it means that silicon is going to be oxidized, right? So it's going to be oxidized and the oxidation number is going to increase. So just without calculating anything, we can deduce that the answer is going to be E. Once something is behaving as a reducing agent, it is going to reduce something else, and in that process, it's going to be oxidized, and if it's oxidized, its oxidation number is going to increase. Now silicon, if we look at oxidation numbers, silicon is Si solid, so that's in its standard state. So therefore the oxidation number here is going to be 0. When it comes to chlorine, chlorine is existing as chlorine gas, so the oxidation state for the chlorine is also 0. But when we form this compound here, SiCl4, the oxidation state of silicon changes to +4, and in the case of chlorine, this changes to -1. So therefore, if we look at oxidation numbers, the silicon changes from 0 to +4, and therefore that's an increase in oxidation number, so it is oxidized. So you can do it based on the numbers or based on the wording of the question. So that's 21. Question 22. We have some acids here. Which one of the acids above require more than 1 mole of NaOH for complete neutralization? So question 22. All right. For the one or two moderators, which are mostly students of my class, feel free to knock out people out of the chat. I have no problem with that. Right? We're here to learn, not here to waste time. So don't just delete the message. You can kick them out as well. Right? Nobody's here to waste time. All right, so I'm seeing some answers in the chat here. So when it comes to neutralization, this is what is happening with neutralization. You have H plus OH minus, and that's going to give you H2, right? This is a neutralization reaction here. Now, when they said in the question, which acids require more than 1 mole of sodium hydroxide for complete neutralization? If you look at sulfuric acid, that's H2SO4, when sulfuric acid ionizes, it's going to form 2H plus SO4 minus. So sulfuric acid has a basicity of 2. There are 2 moles of H plus here. So therefore, if it's 2 moles of H plus, it requires 2 moles of sodium hydroxide to neutralize. So this is true. This is also correct. When it comes to ethanoic acid, that's CH3COOH, this is a weak acid, so it's gonna form CH3, COO minus plus H plus. So therefore, the basicity of ethanoic acid is 1. It's only producing 1 mole of H plus. So therefore, it's only going to require 1 mole of sodium hydroxide to neutralize. So this is out, right? Because you're only using 1 mole of sodium hydroxide. The last acid here, you may not be familiar with it. So in this case here, it's COOH taken twice. So therefore, this acid, the easiest way for me to show you this is to draw it. It's an organic acid, and based on the formula, it is going to look like the structure here. So therefore, this structure represents a diacid. So it has this H here, and it has this H here. So therefore, that's 2 H's. So therefore, the basicity of this acid is 2. So it requires 2 moles of sodium hydroxide for complete neutralization. So this answer is also correct. So the answer is 1 and 3, which is going to be B. The answer is B. So that's 22. So they want to know what is atomic number. We just saw a question previously that asked you for mass number. Now we want what is atomic number. Yes, Ethan. How come you're here? You're not writing an exam? Alright, so this one here, we want to know what is atomic number. So atomic number is simply defined as a number of protons. So the answer is B. I agree, the answer is B. So that's 21. Sorry, that's 23, my bad. This next one here is 24. So this one has to do with energy profile diagrams. Okay, which of the following diagrams best illustrate the course of an exothermic reaction? So we just saw a question there with endothermic. This one is exothermic. Which diagram represents an endothermic reaction? Yeah, looking at comments here. Yeah, so please read your chemistry questions carefully. It's very easy to make a mistake. So read your questions carefully. Let's see what people are saying here. Okay, so a lot of people, so they said which one best represents, so it's an exothermic reaction. When it comes to an exothermic reaction, the energy content of the products have to be less than the reactants. So the only one that makes sense here is going to be E. Okay? So A is exothermic. If we look at the answer for B, B is an endothermic reaction. And we don't know what this is, and we don't know what this is. Because both the energy of the reactant and product is C. So that's 24. Question 25 is based on oxidation reduction again. I know students who like this. Which of the following statement is true for the following equation below? We have magnesium reacting with sulfuric acid. What's the answer for 25? Alright, I'm seeing people saying the answer C. So here's what we're doing here. So they said, so we want to know about the oxidation numbers. That's basically what we're saying here. So you have magnesium solid. So therefore the oxidation number for magnesium is going to be 0. If we look at hydrogen, hydrogen in this case here, because it's an acid, this H here is going to be +1. Now let's see what's happening to the magnesium. When you form magnesium sulfate, what happens here is that we end up with Mg2+. So the oxidation number is going to be +2. And you're also going to form hydrogen, which is in its standard state, so the oxidation number is 0. So those are the oxidation numbers for the magnesium and hydrogen. So in terms of the answers, we're going to say that magnesium is oxidized from 0 to +2. So we change in here, magnesium is 0, and it's changing to +2. So therefore, that's going to be the answer. C is going to be the answer. So that's 25. Question 26. Which of the following factors will usually increase the rate of the catalytic decomposition of hydrogen peroxide? So the reaction they're talking about here is H2O2. That's hydrogen peroxide. And we normally use a catalyst, and you end up with H2O liquid plus oxygen gas. This equation is not balanced, so we need to put 2 here and 2 here. So this is our chemical reaction we're talking about here. So normally we use a catalyst, and the catalyst in this case is manganese dioxide. So we got something like this in the paper 2 this here. So which one will increase the rate of the decomposition? What are they talking about here? What's the answer for that one? Okay, so with questions like this, you need to read it carefully, right? So we want to increase the rate of reaction. So how could you increase the rate of reaction? Increasing the temperature, yeah, that should technically work. Applying external pressure. No, you won't apply pressure here because that only applies to gases. Hydrogen peroxide is actually aqueous, right? It's a solution. Using a larger volume of hydrogen peroxide, well, even if you use more peroxide, that's not going to increase the rate of reaction. If you increase the concentration, it will. So this is out. Use the catalyst in lumps rather than powder. Well, powdered has a larger surface area. So powdered will increase the rate of reaction, not lumps. So the answer is A. So that's 26. Question 27. Which of the following substances does hydrogen have a negative oxidation number? Alright, so people saying the answer is D. So hydrogen, right, typically has oxidation state +1. Typically. However, if one of the rules that we had to learn about this is that hydrogen only has oxidation state +1 except in a compound called a hydride where it is -1. So in terms of hydrides here, D is the only one that's a hydride. So you have to learn this. You have to learn this here. NaH is sodium hydride and the hydrogen has an oxidation state of -1. So that's 27. Question 28. We have electrolysis of aqueous copper 2 sulfate using copper electrodes. What happens at the anode? Somebody's asking how you know it's a hydride. Based on the formula, when you see hydrogen comes after a reactive metal, the compound there is a hydride. So there are some rules regarding oxidation numbers. But I mean, it's multiple choice, so maybe you might get 1, maybe 2 questions at most when it comes to oxidation numbers. So alright, so this one here. So whenever I have to do any question involving electrolysis, I like to draw my diagrams. And then from there, I can make my deductions. So in this case here, I will draw a simple electrolysis diagram. So this is your positive terminal, this is your negative terminal. We have our container with our aqueous copper 2 sulfate. And aqueous copper 2 sulfate is a blue solution, right? So that's what we have here. It's a blue solution here. Now, what's going to happen? So, now they told you that it's aqueous copper 2 sulfate, so that's CuSO4. Aqueous. And they're telling us that we're using copper electrodes. So if you're using copper electrodes, that means that the electrodes are active now. Now in terms of your electrodes here, this here is going to be your anode. That's your positive electrode. This here is your cathode. That's your negative electrode. Alright, now we need to predict what's going to happen. So at the let's start with the anode. So the anode is the positive electrode and the cathode is the negative electrode. So I'm going to give you a little more here when it comes to this particular electrolysis. So the cathode is negative. Now you have an aqueous solution of copper 2 sulfate. So the ions present will be Cu2 plus, SO4 minus. We will also have H plus and OH minus. All of this is coming from the solution because it's aqueous. So now, what's going to happen here? When it comes to, let's start with the cathode. That's the easiest one. If we start with the cathode, that's the negative electrode. So we expect copper and hydrogen to go there. But what actually happens is that the copper is discharged first. So that's Cu2 plus 2 electrons, giving us copper solid. So what is technically supposed to happen is that the mass of the cathode increases. This question is asking us about the anode here. Now what happens at the anode now? So the anode is the positive terminal and you will have the sulfate and the hydroxide ions migrating towards the anode. But because the anode is an active electrode, what actually happens is this. You have copper solid and that copper solid actually turns into Cu2 plus aqueous plus 2 electrons. So this is the reaction that takes place at the anode. So if your copper anode is being converted to copper ions, it means that the mass is going to decrease. So the answer is going to be E. Right, so that's 28. Question 29. Which of the following energy changes occurs during the breaking of a chemical bond? So which of the following energy changes occurs during the breaking of a chemical bond? So we're going back to bonding here. What's the answer for this one? Alright, people saying the answer is B. So you wanna break a chemical bond here. If you wanna break a bond, so let's say you have two atoms here connected by a bond. If you wanna break this bond here, you need to supply energy to make that happen. So therefore, energy has to be required. So bond breaking is an endothermic reaction. Energy is required. So the answer is B. That's 29. Question 30. Glucose is converted to starch or cellulose by what? So you're taking glucose and you're trying to make starch. What's happening in that reaction there? Alright, people saying the answer is D. So this could have come in the paper too, right? Basically, we would have drawn the structure of glucose as this. And if you take many glucose molecules and you join them together, so let's say we have a ton of them. I'm just going to draw 2 here, but you need more than 2. When they combine, you're going to end up with X, O, X, and this is repeating N times. So this is what we call starch, and this particular reaction is a condensation polymerization. So the answer is D. So if we take glucose and you combine it to get starch, that's a condensation reaction. That's number 30. Question 31. Which of the following halogens is a liquid at room temperature? Which one is a liquid at room temperature? Alright, so when it comes to group 7, so this is group 7 chemistry here. So we have fluorine, we have chlorine, we have bromine, and we have iodine. So in this case here, these two here, they are gases. Then we have this one here, bromine is the only liquid. And then iodine here is a solid. So when you go down group 7, you change from gas to liquid to solid. So the answer here is going to be bromine. Question 32. Read this one carefully. All right, so we're talking about propene. Now, propene is an alkene. So propene looks like this. Propene is 3 carbons, and we expect it to have 1 double bond. So this here is propene, or what we refer to as 1-propene. And when you react this with bromine, which is Br2, what's going to happen here, you're going to get a chemical reaction, yes, but that chemical reaction is going to affect your double bond. That's what's going to happen. So in terms of what's going to form here, you're going to end up with this product. So the double bond disappears, it turns into a single bond. The bromine adds itself across this. So in this case here, we end up with 1 product. This particular reaction here is referred to as an addition. So the bromine adds itself across the double bond. So the answer is A. So that's 32. What about 33 here? Right, so ammonia may be produced in a lab by heating ammonium chloride. So if you want to create or you want to make ammonia gas in a lab, you need to have a base and you're reacting that base with an ammonium salt. Now this is something specific in the syllabus. So they already told you you're adding ammonium chloride, so that's the ammonium salt here, and you need a base. So we need to look at the answers here that could be a base. So a base is a metal oxide or hydroxide. So in this case here, calcium hydroxide will be the base for this chemical reaction. The answer is B. Now read this question carefully. I've seen lots of students get this question wrong. We have a compound here and we want to know the name of this compound. I've seen students get this wrong. Right, so let's see what's happening here with this one. This particular one, like I said, I've seen students get this wrong, right? So in this case here, this is what this compound is. So if I were to draw it, I have 1, 2, 3, 4 carbons. So it's 1, 2, then we have OH. So this is what the structure of this compound looks like. Alright, now you want to name this compound. So the first thing you have to look to see how many carbon atoms we have. So we have 4 carbons. So this is 1, 2, 3, 4. So it's bute, right? So the name has to be bute. So that means that this is out and this is out here. So now let's number the longest carbon chain. So this is 1, 2, 3, 4. So your number left to right and your number right to left. So 1, 2, 3, 4. Now, because we have an OH here, we know it's an alcohol. So we know it is butanol. But when it comes to naming your alcohols, you need to give the position of the OH. A common misconception here is for students to say 4-butanol. The thing is, this carbon could be named with a 4 or a 1, but based on our naming convention, we put the smaller number. So it's going to be 1-butanol. So the answer is going to be D. I've seen a lot of students put C as the answer, but the answer in this case here is D. So be careful, right? So that's 34. Question 35. Which of the following substances conducts an electric current and remains chemically unchanged? Yes, I saw somebody said 1-butanol is called N-butanol. That's true, right? Who's this person here? Right? So 1-butanol is also called N-butanol. That's true, right? So what's the answer for this one? Right, everybody's saying copper. So when you're talking about something conducting electricity and it remains chemically unchanged, so they're talking about electrolysis here, right? An electrolyte, when you pass a current through it, it will undergo a chemical change. In this case here, if it's just copper, it's just going to conduct. It's not going to undergo any chemical change. So that's 35. Question 36 to 38 is all based on this set of answers here. So let's start with the first one, 36. Which metal does not react with an acid to produce hydrogen gas? What are they talking about here? So question 36, people are saying the answer is C. Yeah, we're talking about copper in this case here, right? Copper will not displace hydrogen. So yes, the answer is C. What about 37? Which metal is covered with a passive layer of oxide? What about 37? Now, based on all of these metals here, so we have sodium. Sodium will form an oxide called Na2O, sodium oxide. Iron can form iron 2 oxide or iron 3 oxide, in which case it is Fe2O3. That's a possibility, right? Which is really rust, right? Copper will form an oxide as well, which is CuO, and then we also have aluminium oxide. Now, Al2O3, right? So they said which of the following forms a passive oxide layer. Now the thing is, all of these here, right? All of these here have oxides. But when it comes to aluminium, aluminium has an oxide layer that is impervious. It protects the aluminium. So for this one here, I will go with D as the answer for this one here, right? Now passive, yeah, some people are asking what is passive. So passive, so we have what we call active and what we call passive. So whenever something is active, it will chemically react, and if something is passive, it's not going to react. So in this case here, when it comes to passive here, we're going to say the aluminum oxide forms an oxide layer, right? Question 38. Which metal reacts readily with water to produce a strongly alkaline solution? Question 38. A lot of people saying the answer is A. Yeah, I agree, because what happens when sodium reacts with water, you end up with this chemical reaction here. Sodium plus water, you'll get a solution of sodium hydroxide, which is NaOH, plus you're going to get hydrogen gas. So the reason why I get a strong alkaline solution is because you're producing sodium hydroxide, and it is because of the OH minus ions that makes it strongly alkaline. So that's the answer for 38. Question 39. There are so many different versions of this question here. You have to be careful. Cracking is the process of breaking large alkane molecules. Which one of the following represents cracking? I don't even know what FNH is. Somebody's asking if sodium is the only metal. No, sodium is not the only metal that can do that. I mean, it's not in the list there, but you can also get that with sodium, potassium. You can get that with calcium. Right, so this one here, again, you need to be careful. There are multiple versions of this question here. So the gist of what cracking is, you take a long alkene, so basically you're taking a large alkane molecule, and you can break this up using two different methods. You have catalytic cracking and you have thermal cracking. Either way, they are breaking up a large alkene into a smaller alkene, and one of the products that we do get is an alkene. This is the gist of what cracking is. So we're looking at the answers here. So large alkene molecules into smaller alkene and alkane molecules. So this making sense. Let me check the other answers. Large alkene into smaller alkene and alcohol. This don't make sense. This don't make sense. And this don't make sense. The answer is E. So that's 39. Question 40. Hexane has a formula C6H14. Which of the following statements is true about hexane? Oh, thanks for the explanation for FNH. I suspected it's something like that, but I don't I don't teach that, so. People asking about solution video. No, I won't be doing a solution video for multiple choice, right? I'm sure all of the questions that's gonna come tomorrow will all be repeats. Right, people saying the answer is B. So we have a compound here. It's called hexane and it's C6H14. Now what's happening here? Which of the following statements is true about hexane? It's a covalent compound. Yep, that's true. Is it unsaturated? Well, this compound here, if we look at our general formula, it seems to follow CnH2n plus 2, and this here is an alkene. An alkene is considered a saturated compound. So therefore this is out. So anything that has 2 in it is wrong. So look at this here. So you know this wrong, you know this wrong, and you know this wrong. So whether you knew if the third one was correct, the only correct answer is B. This one here, it belongs to a group of compounds known as alkanes. Yeah, that's true. So the answer is 1 and 3. So that's question 40. Question 41. A chemistry student wishes to determine the presence of ethanol. Which of the following reagents will he need from the lab to accomplish this task? Question 41. No, that's not what I said, right? Stop misquoting me, right? I expect all the questions to repeat. That's what I'm saying. I see some of you all asking about maths. Yeah, once I have a little chance, I'll probably do some maths during the week because maths is on Friday. That's the last, yeah, maths is Friday. All right, let's check this one here. Let's try to understand what's happening here. So a chemistry student wishes to determine the presence of ethanol. So for those of you who don't know what ethanol looks like, it has 2 carbons, it has this. So this is structure of ethanol here. You want to test to see, so let's start. So which one can you confirm the presence of ethanol here? So bromine, right? We're not going to get a reaction with bromine, so that's out. There's no double bond there, so we're not going to get a reaction with bromine. Is it an organic acid? Now hold on a sec, let me read this properly. Which are the following reagents? Okay, so it will react with an organic acid to form an ester, yes. But you want to do a lab test to determine the presence of ethanol. When it comes to, let's say potassium dichromate 6, this one here. What's going to happen is that potassium dichromate 6, when you warm it, the final product is going to be an acid. Now, this here is the reaction that we're going to use to determine the presence of the alcohol. So the answer is going to be C, and here's why. You see the potassium dichromate, this reaction here is an oxidation reaction. So the potassium dichromate is K2Cr2O7, which is initially orange. So it's orange initially. And that oxidation number for the chromium is +6. When it behaves as an oxidizing agent, it turns green. So if you get a color change, you know the alcohol is present. So the alcohol is going to be oxidized. The chromium changes oxidation state from +6 to +3. That's what's happening there in this chemical reaction. So the answer is C. Right, so the answer is C for this one here. So I see a lot of students making some requests here. So let me just give you a rundown, right? So I do teach all of those 4 subjects you're all talking about: maths, admaths, chemistry, and physics. So I've actually done my exam preps with my classes already. So we have actually finished. So I'm just, if I have a little free time, I will just do maybe a paper or something. That's it. But I've done a ton of multiple choice and a ton of paper 2s with my students. And I expect all of them to pass, right? But whenever I have time, I'll come live. Somebody's asking what is reduce. Nope. So what's happening here, right? So the potassium dichromate 6 is an oxidizing agent. So the oxidizing agent will oxidize the alcohol into a carboxylic acid. The next thing that's going to happen is that the potassium dichromate 6 is going to be reduced in the process. So the chromium changes from +6 to +3. You get a color change, and the color change goes from orange to green. That's essentially what's happening. That is 41, right? Give me one set. 41, 42. Now, what about this one here? Which of the following gases is not considered to be toxic? Now this one is a tricky question. Which one, read this question carefully, yeah? Some people might misinterpret this question here. It said, which one is not considered toxic? So the answer is actually carbon dioxide. Sulfur dioxide can form acid rain. Also, if you breathe in sulfur dioxide, you can have respiratory problems. The same thing with nitrogen dioxide, because those two gases, when they dissolve with the mucous membrane inside your lungs, you're going to form an acid. So you get this burning sensation. And carbon monoxide is a poisonous gas because it bonds with the hemoglobin in the blood to form something called carboxyhemoglobin. So normally what happens is that the hemoglobin bonds with oxygen and it is transported in your body as oxyhemoglobin. When it reaches the cells, it has a reversible reaction there. So it turns back into hemoglobin and oxygen. So the oxygen diffuses into your blood cells. In the case of carbon monoxide bonds with the hemoglobin, but it forms a bond that is so strong that you can't reverse it. So what happens here is that you become oxygen starved and you're going to die. So that is carbon monoxide. So that's 42. Question 43 is one that CXC likes to bring almost every year. Let's read this question carefully. Talking about soapless detergents. Yeah, if you have high levels of carbon monoxide, yes, that happens a lot in first world countries where they have they light fires to stay warm, and if they don't have enough oxygen to produce CO2, they end up producing carbon monoxide, which is a silent killer. You don't smell it, you don't even realize. Right? Now they have different versions of this question. So we're talking about soapless detergents, right? So remember, when it comes to detergents, we have what we call soapy and we have soapless. Now, soapy detergents are formed or are manufactured from fats and oils. In the case of soapless, they are formed from petroleum. Now, we have two kinds of water. We have what we call hard water. And we have something called soft water. Now, the reason why water is usually hard is because of the presence of Ca2 plus and Mg2 plus ions. That is what makes water hard. Now, when we talk about hardness of water and softness of water, all we do, we take a soapy detergent and you mix it with each of these here. So when it comes to soft water, it lathers easily. So those of you who ever try to bathe in rainwater, it produces soap and it takes a while before you wash off that soap. When it comes to hard water now, right, does not lather easily. And what also happens is that when you mix that soapy detergent, the presence of the Ca2 plus and Mg2 plus, it produces scum, right? So let's see if we can answer the question here. So they're talking about soapless detergents. So more specifically, we're looking at this here. Now, they are made from fats and oils. No, soapy detergents are. They are all biodegradable. That statement kind of, it's a bold statement. They are inorganic materials. So generally soaps are organic, right? They have carbon in them, so this is out. They are not affected by hard water. Well, this statement kind of true because it doesn't matter whether the water is hard or soft. Once I take a soapless detergent and I mix it, it is going to form lather either way. So I'll go with D for this one here. Yeah, somebody's asking, but could it be B? Yeah, B is possible, huh? B is possible. Alright, B, like I said, B is possible. That's why I didn't cross it out here. But I said which is true for soapless detergents. A lot of soapless detergents, so in the case of soapy detergents are generally biodegradable. Soapless, not all of them are. So this is one of those blurry kind of questions here because B could potentially be correct as well. So that's 44. 45 and 46 is based on this here. We have some compounds here, and which compound is the alcohol? Which compound somebody's asking about classes. Yeah, I have students from throughout the Caribbean who attend my classes, not just Trinidad. I have a lot of Jamaican students, Barbados, Dominica, St. Kitts, yeah. Yes, Kayla. There is another version to this question here, right? The one with the soaps. There is another version to it, and the answer in that case had to do with biodegradable. Right? People are asking about the alcohol. So the alcohol is the one that has the OH at the end of it, right? Now this one has an OH here, but this group here is your acid group. So the answer is actually D. D is the alcohol. What about 46? Which compound is the alkene? Which compound is the alkene? Somebody said I missed out 44. I'll go back to 44 in a sec, right? Let me see. Oh yeah, I did. Right, I'll go back. I'll go back. Yeah, going back to 44, don't worry. Which compound is an alkene? So if something is an alkene, it should have a general formula given by CnH2n. If you look at the compounds here, the only one that follows that there is going to be A. Because if you put C2H 2 by 2, you're going to get C2H4. Yeah, so that's the answer there for question 46. It's going to be A. You all said I missed out 44. Yeah, I did. Which of the following substances is a product of the halogenation of methane? What are they talking about here? Right, people saying the answer is C. So we're talking about the halogenation of methane. So methane is CH4. If I react this with, let's say, chlorine gas, right, and this reaction takes place in the presence of UV light, you're going to get CH3, Cl, That's one substitution reaction taking place there. And we're also going to get HCl. So HCl is one of the products that we get, hydrogen chloride. So the answer is C. So that is 44. Well, I love this question here. Everybody should know the answer to this, hopefully. Which is not true of all homologous series of a compound. Question 47. Halogenation is a reaction where you are adding a group 7 element. Group 7 elements are fluorine, chlorine, bromine, iodine. So group 7 elements, what happens here, if you replace hydrogen atoms, that is called halogenation. Alright, so everybody's saying, yeah, the answer is D. Right? Same functional group, that's true. Same general formula, true. Similar chemical properties, also true. So the answer is D. Right? Same empirical formula. That is not true. They said which is not. So that's 47. Question 48. A polyamide is formed by the condensation reaction between a molecule containing what? Empirical formula is the simplest whole number ratio of the atoms in a compound. That's what empirical formula is. The simplest whole number ratio of the elements that make up a compound. Alright, question 48. A lot of people saying the answer is A. Let's check. So you want to form a polyamide. And if you want to form an amide, the linkage that should be present should be this. So that's your amide linkage. And if you want to get a polyamide, you want to get something that contains not just one. So you need this group present, but not just one. You need it to have at least one. Plus, and if you want to get the amide linkage, you need to have this group present as well. So you need to have at least one acid group and at least one amine group. So the answer is going to be E. Right? This is the acid group here, and this is the amine group here, NH2. So that's 48. A solution when treated with sulfur dioxide becomes green. That solution contains potassium what? Yeah, somebody's asking if I'm doing one paper. Yeah, it's just one paper. That's all the time I have, right? Like I said, I've done a ton of papers with my students. That's under polymerization. That's question 48. 48 is based on polymerization. Question 49 is based on oxidation reduction. Somebody's asking about UV light. The only UV light reaction you all need to know would be halogen. That is like chlorine or bromine reacting with an alkene. Amide. So when it comes to polymers, you all need to know the amide linkage and you also need to know the ester linkage. Those are the two linkages you need to know about. Right, so for this one here, we're talking about potassium dichromate 6. You see they talk about the solution turning green. So sulfur dioxide is going to be a reducing agent and it's going to react to the potassium dichromate and it's going to turn from orange to green. So the answer is C. So this one here, what the functional group present in a carboxylic acid is what? Which of the following is present right? I'm seeing people saying B. Yeah, B is the correct answer. So sometimes we normally write it like this. CSEC just drew it a little different here to kind of trick you. So this is C11OH. So B and what I drew there is the same diagram. It's just drawn a little differently. So that's number 50. Question 51. When copper to carbonate is heated alone in a dry test tube, a gas is evolved and a black residue is formed. The gas is expected to do what? What are you talking about here? Right, so people are saying the answer is D. So copper 2 carbonate is CuCO3. That's copper 2 carbonate. But when you heat copper 2 carbonate, they said you get a black residue. So the black residue is copper 2 oxide. And if you're heating a carbonate here, you're going to get CO2 gas being produced. So you're getting CO2. So in SMART, they're asking us, what is the test for CO2? If you want to test for CO2, you're going to bubble the gas through lime water, and you're going to get a white precipitate. Lime water is calcium hydroxide. So the answer is D for this one here. The compound which has the formula, so you have a compound with this formula here. What can we say about this compound here? So people are saying it is an alkene. Yeah, it is an alkene. Alkenes are unsaturated, and I know this because you see this double bond here? That tells me it's an alkene. That's why. So that's 52. Question 53. Which of the following observations is likely when excess ammonia is added to a solution of copper 2 sulfate and the mixture is shaken? So they're asking us some qualitative questions here now. So this is where your lab experience come into play. Yes, Mr. Rock, is because of double bond. Yep. So people saying D plus solution. Yes, when we add aqueous ammonia to a solution containing Cu2 plus ions, what's going to happen is that you initially get a blue precipitate, but if you add excess ammonia, you get a deep blue solution. So the answer is C. And question 54, in this case here, question 54. Potassium is a metal. from the statement alone, it can be deduced that potassium what? What's the answer for this one here? Right, so we're using the fact that potassium is a metal, and based on that fact alone, all we can say is that it is a good conductor of electricity. That's as much as we can say. Nothing else. We can't say it's soft because mercury is soft. It is very reactive, low melting point. We can't say that just based on the fact that it's a metal. So all we can say is D. And question 55. Which of the following procedures can be used to identify ammonia gas? What about 55? How do we test for ammonia gas? Ammonia gas. So ammonia gas will react with moist litmus. We use lime water for CO2, so that's out. Place a burning splint into the jar. That is how we test for hydrogen. Place a glowing splint, that's oxygen. And therefore the answer is going to be D. So basically moist red litmus turns blue for ammonia gas. So that's 55. Question 56. Which of the following is least likely to occur? Alright, I see somebody asking about UV light. All you need to know is UV light is required for alkenes, whereas when it comes to let me say that over. UV light is required for alkenes. So if you take methane and you want to react it with chlorine gas, you need UV light. If it is something like ethene and you want to react that with bromine, there's no UV light required for that reaction. It occurs in the dark as well. Alright, so I've seen some people answering this question here, but this question here requires some thinking. So you all need to know your reactivity series in order to answer this. So you need to learn this off by heart, this reactivity series. Okay, so this is the general reactivity series here. And when it comes to a reaction, you have what we call a displacement reaction. So you can place a metal inside of a solution containing another metal. A displacement reaction will only occur if a metal is higher up in the reactivity series. So if we look at iron and copper, so look at where iron is. Iron is here, copper is down here. Will that reaction take place? Yes, because iron is above copper. So this will take place for sure. If we look at lead and iron, where is lead? Lead is here and iron is above. So this reaction here is not possible because lead is less reactive than iron. So I already know the answer is this one here. If we look at copper and silver, well, silver is actually below copper. So this reaction is possible. Copper can displace silver. And then we have magnesium and zinc. Where is magnesium? Magnesium is here. Zinc is here. So this reaction is also possible. So the only one that is not possible is going to be B. So you need to know the order of the elements in the reactivity series. And the key point here is that a metal higher up will displace one lower down. Question 57 here, there are two, sometimes they ask two parts to this question. Not just one part, but sometimes there are two questions based on the same table here. So we have a table here showing four different metals reacting with water or steam, and then we're looking at the products formed when the nitrate is heated. which of the following is likely to form a soluble hydroxide? Right, so I gather some of you all probably just learn of the answer for this one here. So what you can do, you can put the elements in order of reactivity. But here it is. If you, when it comes to the heating of nitrates, when you heat sodium nitrate and potassium nitrate, so if you heat sodium nitrate and potassium nitrate, that's NaNO3 and KNO3. When you heat these two here, what we end up with is a nitrite. So you get NaNO2 and oxygen gas. For this one here, you will get KNO2 and oxygen gas. So you know that this element Y here has to be either potassium or sodium. When they ask us for a soluble hydroxide, if we look at sodium hydroxide is a solution, so that's possible, that's soluble. Potassium hydroxide is also a solution. So in this case here, I would go with C as the answer. But like I said, there are two questions associated with that table. And question 58. So we have fermentation of sugars using glucose as a substrate can be represented by which equation? So we're talking about fermentation. Some people talking about the reactivity series. So when it comes to the reactivity series, you have reactivity series and you have electrochemical series. So the position of where is it? Yeah, the position of sodium and calcium switches in the electrochemical series. Alright, so based on the answers here, right, when you take a sugar and you ferment it, we expect to get ethanol. When you look at all the answers, only one of them is giving us ethanol as the answer. So the answer is going to be C. This is the ethanol here. Only one reaction is actually giving you the ethanol. So that's 58. Question 59. Which metal appears between copper and aluminium in the reactivity series and is an important component in hemoglobin? I just spoke about hemoglobin there. What are we talking about it? Okay, people saying the answer is iron. Yes, when it comes to hemoglobin, iron is the central element that is there. You also need to know, so there is an exam question that has chlorophyll. So chlorophyll is what we find in plants, and the main element in that case is magnesium. So be aware of that. And question 60. Which of the following gases will give a positive result with dry cobalt chloride paper? Which of the following gases will give... So this is a specific test they're asking us about here. What are you talking about this last one here? When you see cobalt chloride, right? Somebody is saying there will be no repeat. Don't believe that. That's not true. Right? That's definitely not true. I can tell you that you are going to get repeats tomorrow. All right, a lot of people saying the answer is D. Yeah. So how we test for water, we actually use cobalt chloride paper to test for water. Okay, so the answer is H2O gas, which is steam, right? Once steam touches cobalt chloride paper, you're going to get a color change, right? So like I said, I had a little time, so I just went through this paper with you guys. So don't worry about what people saying. Oh, they're gonna. Those are people who just trying to cause fear in you guys. I expect a lot of the questions to repeat. I expect a ton of them to repeat, if not all. So I just want to wish everybody good luck in the chemistry exam tomorrow, right? Please read the questions carefully. When it comes to multiple choice, chemistry questions can be very tricky. So read the questions carefully. Take your time. An hour and 15 minutes is a lot of time to complete the paper. Once you finish before time, spend the time reviewing the material, right? Reviewing your answers. Double check everything. Don't leave out any questions. You're not gonna lose marks if you leave out questions. So make sure you answer all. So I just want to wish everybody good luck in the exam tomorrow. You all could post online if you found it was easy or not, right? So good luck, everybody. Enjoy the rest of your afternoon. Be safe. And hopefully during the week, you might see me for maths along the way, right? Take care, everybody.